About scientific notation. This time we're going to focus a little bit more on small numbers. Okay, so previously we were talking about making really big numbers more readable using scientific notation. Now we're going to talk about really small numbers. And we'll just kind of jump into this with some examples because it's very similar to large numbers. We just go the other way with our decimal point. Okay, so for example, and this is on page 45 of your book if you'd like to look there, and the Explore activity, and I do recommend just going through and seeing if you can figure this out on your own, because I think you can. But then come back and look at the video and make sure you didn't miss anything. Okay, so just like we did large numbers as something between 1 and 10, so 1 through 9.99, okay, somewhere between 1 and 10 times 10 to a power, we're going to do the same thing with small numbers, but our exponent's going to be negative instead of positive. Okay, so the example that they give in the book is a typical human hair, and you can go home or actually are at home, most likely. So go ahead and pull out one of your hairs and look at it really closely. And it has a diameter of 0.00025 meters. All right, so 0.00025 meters. What would this be? This is tens, hundreds, thousands, 10,000s, 100,000s, millions. So 25 millionths of a meter is the diameter of the human hair. So you guys can think back and remember, oh, I can convert that into a decimal as a rational number. All right, so we don't really want to write it this way because we want not to have to write a whole bunch of zeros before 25. So remember, it has to be between 1 and 9. So we're going to use 2.5. We can't use 25 because 25 is greater than 10. And we can't use 0.25 because that's less than 1. So 2.5 is what we're going to start with, and we're still going to multiply it by 10. Okay, and if you remember last time when we were doing really big numbers, the number that we put right here is how many times we'd move it to the right, and that would give us our number. Well, we don't want to do that for this one because if we move it to the right, we get a big number. We want a small number. We want to go this way, right? But it's the same idea. The only thing is our exponent's going to be negative. And so if we start here between our 2 and our 5, which is just like this, right, 2.5, and we're going to count how many spots to get to the decimal place. So that's 1, 2, 3, 4, 5. So 2.5 times 10 to the negative fifth power should be 0.00025. And just to check, just to make sure, we're going to put this into our calculator, and hopefully I don't have to redo this video because it's completely wrong. 2.5 times 10, and on your calculator, to raise to a power, there's usually a little caret. It looks like a little partial triangle with no base, or x to the y. So 2.5 times 10 to the negative fifth power is 0.00025. Yes. Okay, so that is correct. So now I don't have to redo the video and pretend that I didn't make a mistake. Just so you know, I have done that in the past. Okay, 2.5 times 10 to the negative fifth, that would be our answer. And you can look through the rest of this activity in your book if you would like to. Okay, so we're just going to do a couple of more examples. I'm going to leave this as the introduction to small numbers in scientific notation, and then I'm going to go ahead and do another video with a couple of examples.